Alright, now let's work on some examples with our net ionic equations and our predicting products with solubility. Remember that when we are looking at our net ionic equations, there are 3 steps we have to do. First, we have to come up with our chemical equation. And predict those products. Then we have to do our complete ionic equation. And after we have identified our complete equation, we can create our net equation. So, starting off with our chemical equation, we have iron 3 chloride and potassium hydroxide. Pause the video here and set up your chemical equation with predicting products using your solubility rules. Alright, let's look at what we have. Iron, with its positive 3 charge, bonds to chlorine. We need 3 chlorine because we have a negative 1 charge. Potassium hydroxide. Potassium is representative with a positive 1 charge. Hydroxide is our polyatomic with a negative 1 charge. They're balanced. Looking at our solubility rules, iron 3 chloride is going to be aqueous or soluble, and potassium hydroxide is also going to be soluble. Because we know this is a double replacement reaction, we're going to bond iron with hydroxide, which is OH and not HO. Again, make sure that you have that iron balanced out. And our potassium will hook up with that chlorine. Looking at our solubility rules, the potassium chloride is going to be soluble, while our iron 3 hydroxide, is going to be insoluble and form our solid. Make sure that you're always checking that these equations are balanced. As you can see, this one is not. By adding our coefficient of 3 here and here, we have balanced our equation. Our next step is going to be to write out the complete ionic equation. For our complete equation, we do need to make sure that our subscripts and our coefficients are taken into account. Pause the video and write out the complete equation. Alright, looking at this, iron 3 chloride is aqueous, so they split up. Iron has that positive 3 charge. It is aqueous. Chlorine has a negative 1 charge. It is aqueous. And we have 3 chlorine. Instead of leaving that as a subscript, we are going to move that to a coefficient now. The reason we move it to a coefficient is because chlorine on itself, or by itself, is not a molecule containing 3 chlorides. Instead, putting it as a coefficient identifies that this is simply 3 chloride ions dissociated in a solution. The same thing is going to happen to our potassium hydroxide. We have 3 potassium ions with a positive 1 charge in an aqueous solution. And we have 3 hydroxide ions with a minus 1 charge in the aqueous solution. On the other side, we have iron 3 hydroxide as our solid. Remember, solids are insoluble, they don't dissolve. So this is left all together as iron 3 hydroxide, and it is a solid. The potassium chloride, however, is aqueous and will dissociate. Double check and make sure that your complete ionic equation matches what we've done here. And then move on to your net equation. Pause the video to identify what your net equation will be. And then when you're ready, unpause it to watch me go over it. Alright. On this side of the equation, we know what our precipitate is. It is that iron hydroxide. We're going to cross out the two ions that are not a part of our precipitate. We're then going to look on the reaction side for potassium and for chlorine and cross them out on the reactant side as well. This leaves us with iron ion, hydroxide ion, and iron 3 hydroxide precipitate. We rewrite them to form our net equation. Alright, we're going to do another example together. We have sulfuric acid and barium chloride. We haven't gone over how to name acids quite yet. So, for sulfuric acid, we know that it's an acid, so it's going to have a hydrogen at the front. We get this ending of ic from the ending 8, and we pull that sulf from there too. So we're using sulfate. Sulfate is a polyatomic ion, which is SO4. SO4 has a -2 charge, so we need 2 hydrogens. Sulfuric acid is H2SO4. You know how to do barium chloride, so I'm going to stop here and let you finish writing out our chemical equation. Alright, so we have our sulfuric acid, and we have barium chloride. Barium is a representative element. We know that it has a +2 charge. Chlorine is representative with -1, so we have 2 chlorines. We use solubility rules to identify that both of these compounds are aqueous. Now to predict our products. Again, because this is a double replacement reaction, we are going to have barium hooking up with sulfate. Barium's +2, sulfate is -2, so they are happy. And we have HCl. This is also an acid. It is hydrochloric acid. Looking at our solubility rules, we know that the barium sulfate is going to form a solid or a precipitate, while the HCl is going to form aqueous. Make sure you double check that it's balanced. This equation is not, so we need to add a 2 in front of our hydrochloric acid. If you had trouble setting up that chemical equation, no worries. Pause the video and write out your complete ionic equation. Alright, so our sulfuric acid is going to dissociate, giving us hydrogen with that positive charge, soluble. We have 2 hydrogens for our subscript here. That's going to come out and be our coefficient. Sulfate has that -2 or 2 minus charge and is soluble. Barium has that +2 or 2 plus and is soluble. Chlorine, we have that subscript of 2 that's going to pop out as our coefficient with a -1 charge and is soluble. On the other side of our equation, we have barium sulfate forming our precipitate, so that doesn't split apart. However, our hydrochloric acid does. Now to form our net equation. Remember, we identify our solid, cross out our spectator ions on both sides, and rewrite our complete equation now as our net equation. You may see always the cation or the positively charged ion written first. Other times you might not see this. Here is our answer. I hope that you're feeling more and more comfortable with this as you practice through it. Remember, we worked on writing out our net ionic equations and identifying insoluble and soluble products based off of solubility rules.